Alright, so for everyone in Physics 184, right? This is the last problem of Chapter 27 in Mastering Physics. So question 18, right? So let's get right into it. It's asking, well, for the first part, it's asking us, how long must the 0.66 millimeter diameter aluminum wire be to have a 0.48 current when connected to the terminals of a 1.5 volt flashlight battery? So things right off the bat to know. I mean, you won't find this anywhere, or you could probably Google it or find it in your book. The resistivity, not the power. Okay, you'll find this out in chapter 28. The symbols look the same to me, at least. Well, the resistivity of aluminum is 2.8 times 10 to the negative 8 ohms per meter. And again, I'm just going to write out how 1 ohm is equal to 1 volt over amperage, right? So yes. So we're asked to find the length. So one equation that would get the job done is this one. The current is equal to the area divided by the PL, or resistivity, not the resistance, but the resistivity, not the power, times the length, times, change in V. So we know everything because we can get the area from the diameter. We can find P from the book, change in V is given, I is given. So we just have to rearrange ourselves for L. So L is going to be a little weird. So if I multiply both sides by L, we're going to get L on this side, but we're going to divide both sides by I. So it's just going to be A over PI times change in V. So let's get cracking with this problem. So area, I want to pressure yourself for the area first. Area is just going to equal pi r squared. So area is just going to equal to pi r. We're given a diameter of 0.66 millimeters. They'll never give it to us in meters, so we're just going to convert for them. Yeah, because like 10 to the minus 3. Divide by 2 because we need a radius, and we square it. So let me go ahead and type this in a calculator. So we get 3.42 e to the negative 7 meters squared. Now we can solve for the length. So we get 3.42 e to the negative 7 meters squared divided by resistivity, which is 2.8 e to the negative 8. I'm just going to use these units instead, so stuff cancels. So we get V over A times it by meter. Yep. I is just amp, and remember 1 amp is equal to 1 coulomb per second. Am I right? Yep. So we have 0.48 coulomb per second. Or we can just leave it as amps because we already have amps here, so we don't need to convert that. We don't need to worry about this nonsense right there. It's not really nonsense, but we just don't need to worry about it right now. Okay, that could stay, whatever. This line's too long. And we can multiply by the change in V, the voltage, which is 1.5 volts. Let's cancel units. This cancels with that cancels this, and one of these cancels with the top there. I don't know what just happened over there. We're just going to pretend that didn't happen. But for length, if we type this on a calculator, give me a second here. We get a length of 38.18 meters. That's a pretty good length, I'd say. Oh, I guess you can't really see. I guess you don't need to see. The question's right here. What was the question again? Oh, well, to find how long must be as the wire, I guess. Okay. Well, what is the current if the wire is half its length? Well, now we just gotta use the original equation right there because we have everything. So we just gotta find I. So if we divide the length by 2, that'll give us 19.09. That's just half that one, right? This is half of that. So I is equal to the area, which we already found, which is 3.42 e to the negative 7 meters squared. I don't know why I keep forgetting my square here. That's meters squared. That's the area. Although I didn't remember up here, it looks like. P was found from a textbook or Google. So we've got 2.8 e to the minus 8 ohms, which is V over A times meter. L is just 19.09 meters. And then change in V is the same, 1.5 volts. So we will cancel stuff out. So it looks like the meters with this meter squared cancel out, and we're left with amps, which is exactly what we want. So if we do, or if we just type in the calculator, we get about 0.959 or 0.96 amps. And that is it for this problem, guys. And that is it for chapter 27.